I am going to record this for the other classes because they reviewed on Friday. And as you probably felt on Friday, they weren't super focused. Were you guys super focused on Friday? Not super focused. That being said, we started reviewing and I passed it out. And like within 2 minutes, I had a million questions. So let's look at the review / look at your notes. What is something that you should probably know for this quiz? If I were to make like a little like a cheat sheet or like a sparknotes paper, what would I put on here that we need to know for this quiz? Maybe what does the first question ask us? How to find the measure of the interior angles. Okay, so I think that there's a couple ways that we can think about this. We have interior angles, and then we also have exterior angles, right? And we have the sum of the interior and the exterior. And then we also have how to find like one individual angle, and it must be a regular polygon. This was 6.1. Does anyone remember how we find the sum of the interior angles? What's the little like formula we did there? Times. Very good, Danielle. N minus 2 times 180. I like to put both those in parentheses. So if I want to find the sum of the interior angle, you just take the number of sides that you have or the number of angles, and that's your n minus 2 times 180. That's going to give you the sum. Okay, how do I find one exact angle? If that's the sum and I just want to find one of them, what do I do now? Yeah, Corey. Divide that equation by n. So what that's saying is a regular shape. Do you guys remember what regular means? Anybody? Nod with me if you know what regular means. Shake your head if you don't know what regular means. Say again? It is closed off, but that's not what regular means. All the sides are equal, and thus what else? Good. All angles and all sides are congruent. Very good. Okay. Those are my interior angles. All my sides and all my angles are congruent. What about exterior angles? Do you remember how to find the sum of the exterior angles? 360. When is that? Is that just a pentagon or a triangle? Everything. Everything. The sum of the exterior angles is always 360. Always, 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 always. So if the sum of the exterior angles is 360, how do I find one exterior angle? 360 divided by how many I have? N. Good. All right, so we just did sum of the interior, one interior, sum of the exterior, one exterior. I think that's like half of this first page. Anything else on 1 through 17 that you might have a question on yet? Do we feel like this is a good starting point for like the first part? Feeling good so far? Okay. Now, I said 1 to 17 because once we get to 18, we have a parallelogram. And parallelograms are a little bit different. Now, with parallelograms, we should know 5 things. If I tell you it's a parallelogram, then you should be like, okay, cool, Miss White, I know 5 things. Do you think we could list those out? Hint, this is 6.2. So if you go to your 6.2 notes, we have all 5 of them written super nicely. Opposite sides are congruent. Good. I'm going to say if quad is p-gram, and I'm just going to write that once, and we're just going to assume that that's true for the rest of them. So if a quad is a parallelogram, if I tell you it's a parallelogram, then like Jonathan said, opposite sides are congruent, right? All right, that's one thing. Number 2, what's the next thing I know? Consecutive angles are set. Very good. And I just took a really long spring break. So what does supplementary mean? Add up to 180. Good. Yeah, Cora, what's another thing we know? Good. And that's basically our definition. So if it's a parallelogram, then that means by definition, its opposite sides are parallel. Do you know what I'm doing when I do this? This little like quotation, that just means like I'm carrying down the if. Does that make sense? It's like if I have like this if statement that comes down here and comes down there and then comes down there. Is everyone okay with that? I don't want to throw more notation. You're like, I'm just writing what Miss White says, but I have no idea what that means. All right, I've got two more. What's one of the other things? Yeah, Corey, give me one. Good. Diagonals bisect each other. Is there another way to say that? They share a midpoint. Good. If you only like one of them, you don't have to write both, but I write both just in case I can get anybody else. And then one more. You're going to feel silly that this is the last one that we came up with. It's a pretty easy one. Opposite angles are congruent. Good. Yep, those little quotations are just if quad is p-gram, if quad is p-gram, if quad is p-gram. So yeah, you're okay with that? Okay. I just wasn't gonna write that over and over and over and over again. And so what I'm saying here is like, if you are told it is a parallelogram, you can assume all of these things are true. So that should help me on number 18 to know like which sides are congruent, which angles are congruent, whether angles are congruent, whether they're supplementary, all that fun stuff. Okay. Now that is 6.1 and 6.2. The only thing that changes about 6.3 is that we're essentially doing the converse of all of those statements. So I can prove something is a parallelogram by doing the first thing, by saying my opposite sides are congruent, so thus it's a parallelogram. My consecutive angles are sup, thus it's a parallelogram. So what I will probably think of right here is if we know it's a parallelogram, we get to know all these things. But in order to prove it's a parallelogram, then we have to prove like if opposite sides, actually, let's go a little bit more specific. Let's go if two pairs opposite sides congruent, then it's a p-gram. So what we can do is take all of those statements that I just wrote in orange and rewrite them with them first. So if two pairs of opposite sides are congruent, then it's a p-gram. The next one we said, if it's a parallelogram, then consecutive angles are sup. We can say that as well. We can say, we make it a little bit more specific here by saying if one angle is supplementary to both its consecutive angles, then it's a p-gram. I'm running out of room, so I didn't write p-gram all the way out. Is this ringing some bells? Okay. I'm going to keep doing that because if you remember, there's one extra way to prove that something is a parallelogram. So like the next one says, if it's a parallelogram, then two pairs of opposite sides are parallel. So I can say if two pairs opposite sides parallel, then we know it's a p-gram. If the diagonals bisect each other or if the diagonals share a midpoint. And I'm actually going to phrase it that way. I think that will make more sense later on. If diagonals share a midpoint, then it's a parallelogram. And then the last one we said is if opposite angles are congruent. And again, we'll say if two pairs, opposite angles congruent, then parallelogram. Now there's one more way. So I'll kind of give you a second. Does anyone know the last way I can prove it's a parallelogram? The rest all matched up with properties we knew of parallelograms, but the last way to prove is kind of a combination of these two things. It's a combination of these two things. Anyone think they know? It goes, if one pair of opposite sides is both parallel and congruent. Very good, Daniela. All of these said if two pairs, but if I just had one pair of opposite sides that is both congruent and parallel, then it's a parallelogram. So you don't necessarily have to write this down. I'm just kind of reminding you all of these things and want to bring them back to your reference. Before I release you to work on the study guide, I did want to finish a little bit of that 6-3 notes. We started like the last page with the coordinate plane and we didn't finish it. So I wanted to kind of go over that just to remind you what those could look like. I promise there will be one question like that on the quiz. If you look at your study guide, the one that has like the coordinate plane, that's like what we're about to do right now. And again, this is recorded, so I will put this online. So I've got like a little sparknotes sheet. And if I didn't make this, I'd maybe take a picture of this right now, or I'd kind of look back at your notes on where this is at so that you could take time to kind of refer back to the sheet as you're studying. Okay. So I'm going to hit back to that 6-3 notes really quick because I want to finish that page. We did the slopes, right? Can you guys get your notes out? Go to that last page really quick. Too far away to actually erase anything. Everybody here on this last page with me? Signs of life? Yes? Yes. Okay. All right, we did this first problem together, right? You guys already have this problem done on your notes, correct? This is us proving that this is a parallelogram based on the picture that we have. So what I started with the other day was showing that opposite sides have the same slope. And if sides have the same slope, then that means that they are parallel to each other. So we were like, okay, if we can prove that they are parallel by showing they have the same slope, then we can prove that they are congruent or that they are a parallelogram. So what we did the other day is I think a pair of us did A, B, and C, D to see that they had the same slope as one. And then another group of us did the slopes of BC and AD, which are opposite sides, and found that their slope was -2/3. So there are 3 other ways that we could do that. And so this method 1 that I said, what you had to do was you solve for 4 slopes. And I actually really like that method because I think it's pretty simple. 4 slopes, I think, is one of the easier ones that we can do. Okay. I will never ask you to do all 4 of these, but I'm showing you these are the 4 options I could ask you, and I will definitely ask you to do one of them. Does that make sense? Okay. The next method says show that opposite sides have the same length. If they have the same length, do you know another word for length? distance. If they have the same length or if they have the same distance, then that means that they are congruent. So if we can prove that their distance is the same, then we can show that they are congruent. So in this case, I have to show that both pairs of opposite sides are congruent. So I have to do a distance formula for AB and for CD to see if those are the same. And then I would have to do a distance formula for BC and AD to show that those are the same. So on that one, I would be doing 4 distances. Let's do this, but let's break it up like a little bit nicer than having to do 4 distance problems each. We'll kind of go by like parts of the classroom. We'll each do 1 distance formula. That being said, do you remember the distance formula? Let's go over that. Distance formula is D equals square root. And it doesn't matter what order you do these in. I always do x2 minus x1, but you could say x1 minus x2. It doesn't matter as long as you match it with your y. So since I started with x2, I need to start with y2 minus y1 squared. All right, so we're gonna divide and conquer and we're gonna decide what my distances are. So let's do Jennifer's row and Lucas's row. I want you guys to find distance for AB. Molly's row, I want you to find distance for CD. So my middle row finds CD. Mackenzie, I want your row to find BC. And Jonathan, I want you guys to find AD. So then you should be able to kind of turn to somebody next to you and say, is your distance the same as mine? And they should be able to say yes. Okay. I will try and do at least one of them, if not all of them, really quickly. -1, 5 minus 3. I'll come back to my work, but I have A, B, and C, D already done. Quinn, I know you're doing that distance formula, right? Of course. All right, I got both. I got all of them, except I didn't do 52. Does 52 factor down? 2 radical 13? Okay, perfect. I was rushing to get it done, so I didn't do that. Radical 13. But either way, does it matter if what the root 52 simplifies down to? No, because my opposite sides have the same distance. A, B, and C, D are opposite sides. Do they have the same distance? Do B, C, and A, D have the same distance? You thought what?
I thought it was an 8 or a 3.
Oh, all the way up here. Oh yeah, that'll get you. The good thing is if you show me all the right work with the wrong number, it'll all be okay. You don't have to have all of this copied down. I will just keep this up again if you want a screenshot or if you want to see, but if you know how to do distance, or you can go back on your own. But we've done distance many times. I just wanted to review that, okay? I'm almost done with you guys. You ready for the next method? Is anyone still looking? I'll give you a second. I see some of us are still looking. Remember, these are just your notes. I'm not going to come and see, did you do this or not? But I saw that all my distances were the same. So AB's distance is the same as CD, and BC is the same as AD, which means that the sides are congruent. So that makes it a parallelogram. So I can use 4 slopes to prove it's a parallelogram. I could use 4 distance to prove it's a parallelogram. Method 3 says show that just one pair is both congruent and parallel. How do I show that it's congruent again? Which formula do I use to show that they're congruent? Distance. Congruent is distance. So I'd have to do distance to show that one pair is congruent. How many sides is one pair? 2. Good. So I'd only have to do 2 distance formulas. And to show that it's parallel, what would I have to do? Slope. So I'd have to do 2 distance and 2 slopes. A little like hint, word to the wise, I often ask you this one because it asks me to, it has you show me both distance and slope, which gives me a better idea of what you know. So like this is a one that I might ask you on the quiz tomorrow. So if I ask you 2 distance and 2 slopes, then we would have to show that one pair of sides is both congruent and parallel. I'm not going to make us do that again because we already have the work above, right? Are the distances for A, B, and CD the same? Did we just find the distances for A, B, and CD to be the same? What about like last week or 2 weeks ago? Did we find that A, B, and CD were parallel? Yeah, they had the same slope. So since they are congruent and they are parallel, then it's a parallelogram. We lucked out doing no work because we already did the work. Okay, and the last one I think is the easiest one. It says show that the diagonals bisect each other, which means that they have the same midpoint. Do you remember midpoint formula? Uh-huh. Good. And it doesn't matter what order you add them in, but you have to add them. The biggest mistake I see is that we make these pluses, minuses. So remember, midpoint is adding. Add, 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 add. So we're going to do midpoint formula. And the fun thing about midpoint, and that I like this one a lot, is you only have to do 2 of them because we're just doing the diagonals. So you just want to do 2 midpoint formulas to prove that this is a parallelogram. But I need you to remind me, what are the diagonals of this shape? What ones are the opposite of each other? AC and BD. Very good. So we would find the midpoint of AC and BD. And the reason I make sure that we know that is because if you did the midpoint of like AB and then the midpoint of CD, you would not get the same number. So we have to make sure that we find where they intersect each other. A, C, and BD, just based on the picture, I feel like they should have the same one, but let's go do the math and check. So let's again separate, divide, and conquer. Boys, can you find the midpoint for AC? And girls find the midpoint for BD. Just worry about finding one of them because I don't think we need to practice that skill for much longer. Let me go find those. 1 + 9, 3 + 1. + 7, 5 + 9. And we all should have gotten the exact same answer, right? We all should have gotten 5, 2. And did you? Perfect. Okay. All right, so I'm sorry to have to like spend some time kind of instructing, but I wanted to make sure the rest of our review time was super effective. So we have kind of the shortcut notes that I did on the other page. We finished this page. And remember, this quiz is on 6-1, 6-2, 6-3. The rest of the class is for you to study, to work on that. I'm going to pass back any papers that I have for you to have that to study as well. And that's kind of all I've got. If you need help, I'm here to help. Anybody have any questions? Awesome. Okay, I'm going to end this recording.